Good morning and welcome to today's Quick Bite. My name is Madeline Holzer. I'm the Education Event Specialist here at Zahn. I'd like to welcome you today to our Quick Bite with milling tools, what everyone needs to know by Sierra. Today our presenter is Greg Everett. He's the Vice President of Business Operations of Sierra Dental Tool. Just a little bit of housekeeping before we begin. I want to make you all aware of the questions tab in your toolbar. At the end, we will have a chance to have some Q&A live with Greg. But if you do have questions, we implore you to use that questions tab and we will address them as time allows. Welcome, Greg.
Well, thank you, Madeline. Appreciate the warm intro. I'd like to lead by thanking the Zahn team and everybody over there for the opportunity to get in front of the audience here again. You know, we've done quite a few of these, but I'm personally a big fan of this new format with the quick bite. You know, I think that keeping things short and sweet is a really good way to kind of densify the content and add value. So I will actively try to avoid rambling, but no guarantees. So quickly, for those of you guys who don't know, Sierra Dental Tool is in partnership with Zahn. We supply the best milling tools to the market that are third party, and our entire philosophy is about delivering clear, repeatable value to the lab and helping labs be more efficient. A little bit about me. I am running business operations over here at Sierra now, but I've been in the industry since 2006. I started at a dental lab here in Southern California. In fact, I'll throw a quick plug out there. Nash Dental Lab, great operation over there. And I learned how to break everything. Broke and fixed pretty much everything that had to do with digital. It kind of grew me into a position to where I became fairly good at helping people with digital. Smash forward, been with Sierra now for almost 3 years, a little over 3 years, and really enjoying it because on a daily basis I get to directly help labs, and that's extremely satisfying on a personal level. So we'll jump into it here a little bit, and really this is not going to be like a sales pitch. That's really not the point of this. As much as I hope you use our product, everybody makes their own decisions. But I just wanted to take this opportunity to go through some of the things that the Sierra team and I observe, on a daily basis with labs of all sizes, from small, mom and pop, all the way up to the big DSO operations. There's a couple of through lines that we typically run hard. Like there's a few things that if every lab did, they'd be more efficient, and their bottom lines will improve. So basically, current state of business in the industry. Majority of labs now have mills. In fact, I'm going to go out on a limb and say that 100% of the people who are on this webinar probably have a mill. Otherwise, you might not have clicked on it based on the title. So we have that as the current state of business, and it happened very fast. Over a few years. Initially, you have that bleeding edge, leading edge sort of thing with new technology, and then it ramps, and you end up with the mass adoption. And we're well into the mass adoption phase now. But the major issue with that, or at least observation that we've made, is that education and knowledge tends to lag behind that mass adoption. And on the most simple level, a laboratory, basically they want a box that produces units that they can sell to their doctor. They literally just want to push a button and have the unit come out. The day that somebody comes up with that solution is going to be amazing, but it doesn't exist. There is all kinds of nuance to it. It goes deep, and so again, I'm not going to ramble, but I could do this over 3 or 4 hours probably and really go deep, but I'll try to stay high altitude here. So in our daily kind of support conversations that we're having with end users and even the Zahn team, we're seeing some of those through lines, and that's what I want to get into here. So we're going to cover some of the things that you should be tracking in your operation. There's only a couple things that really matter. We'll go over that. We'll go over how the actual machine is affecting your outcomes and how to optimize that. And then quickly go over the trade-offs, the decisions you can make as a lab when you're doing this digital production. So let's move on here. Okay, so let's talk about some metrics. I've always been of the philosophy that if you don't measure it, you don't have any visibility. If you don't know what you're doing, then how are you going to improve it? So I like to think about a couple of things when I'm designing or consulting on a digital workflow. We really want to know, like, I want to know down to the penny exactly what that unit cost me. In reality, that's not really achievable, but I've always been surprised by how many lab technicians or owners that I talk to, and they don't really know within a ballpark exactly what that unit is costing. So we want to pay attention to labor costs, material costs, and the big one, internal remakes. Those can kill. So when we're talking about production efficiency, there's basically 3 things that you want to address. Units per day. So before you even go out and buy a machine, or even if you're retroactively looking at your business with machines, you want to run a quick break-even calculation. Like how many zirconia units do you need to mill on a daily basis in order to make sure that mill is making money. And right now it's typical that your pre-mill buying decision, typically people will outsource for a time until they reach a certain level. And then there's those of us who have if we build it, they will come sort of mentality. But either way, we want to be very aware and have that be a high visibility of, like, am I making money with the equipment? Too many people I've talked to who have paperweights, and we don't need that. So definitely track your daily production. Do it on an average. I mean, days fluctuate, obviously. The next thing is your material usage itself. Now, it's surprising. Like I've even walked into some very substantial milling centers and found that they don't really do a good job with this. Typically, if you're nesting efficiently, you're gonna see a average of around 18 full contours in a puck, and that's usually that's a normal breakdown of posterior versus anterior and bridge. But if you're in the neighborhood of 18, then you're doing good. The way that we optimize material usage is through nesting. So there's 3 rules to nesting. Do not create islands of material. So don't nest around and make a little piece of material that you can't use. Next one, do not create peninsulas. So think about the state of Florida. You can't nest into a peninsula. So you always want to stack them evenly, kind of like, think about Tetris. It's basically dental Tetris. And the third and last thing is, around the unit when we machine, we use a little offset space so the tool can reach the part. Overlap those offsets. A lot of labs don't, and like the difference between overlapping and not overlapping is like 20%. Like you could jump from 15 units to the 18 units if you go to overlap. So highly encourage looking at those three things. Track your unit per puck metric, and you'll find that you can find optimization there. Now, here's where my bias is, for obvious reasons. Your units per tool or cost of tool per unit, that can be substantial. For instance, early in Sierra's kind of growth curve, probably circa like 2008, we had a beta test site with a 3M lava machine. They had a number of them. Some of us might recognize Issaquah as being the name, as a pretty big. They were a big deal, and they still are. Now we partnered with Issaquah back in the day and supplied in our CVD diamond tools, and we saved them tens of thousands of dollars in tooling. Like it was nothing to shake a stick at. And that recipe, in partnership with Zahn, has been really the secret sauce to the Sierra brand. We don't have any gimmicks or we always, my philosophy and Sierra's philosophy is to under promise and over deliver. There are other ways of looking at it. Oh, we got to get sales, we got to throw a gimmick out there. That's just not how Sierra operates. We're always about creating real tangible value for the lab. So you have to track your number of units, and at the end of the time period, make a calculation based on your tool cost, and you will inevitably find that it's more cost effective to get a better tool up front, leave it in the machine for a month, 2-3 months, than to buy the cheapest tool you can find and change it out really often. And really, like, tracking the number of units, I made a prop. This is all you need right here. Sticky note on the machine, make some hash marks. And then when the tool is done, write it down in a notepad. Extremely, extremely easy. Some of us might remember the show Mythbusters. I loved that show. And one of the things they always said, the only difference between screwing around and science is writing it down. So just write it down, pretty easy. Okay, let's talk a little bit about machine health. So I have kind of a worn out metaphor, but I haven't found a better one, so you're gonna get it again. The tool is similar to a tire on your car. You can buy the best tires in the world, but if you drive it like Ken Block in this rally car, tires you're not gonna get 40,000 miles out of those tires. Or if you hit a curb and your car's out of alignment, you also will scrub your tires clean and you won't get the life. And so if the mill isn't tight and it isn't properly maintained, tool life suffers, and also your milled result suffers in tangible ways like surface finish and fit and all kinds of fun things. So, like, literally the easiest thing we can do in a lab is focus on machine health. I've walked into so many different labs where they've got a $40,000 piece of equipment there, and it's just completely neglected. Like, just it kind of saddens me, because it's almost like buying a brand new car and then just beating the living tar out of it. Except that car is making money for your livelihood, right? So the first thing that we want to do when it comes to regular maintenance procedures is, on a daily basis, clean it, vacuum it out, wipe it down, keep it immaculate. And some people think, oh, it gets dirty again anyways, it doesn't matter. It really does matter, and for this reason: zirconia is abrasive. It's basically sandpaper. And so if in fact, if you don't believe me, next time you're in Home Depot or Lowe's, just walk into the sandpaper section, and you'll see zirconia sandpaper. You can get zirconia grinding wheels. It's an industrial abrasive. And so when you get that abrasive between two sliding metal parts, they do not like it. You get lots of wear. And once you get that wear, your machine gets looser and everything just goes downhill from there. So protect your investment, keep it clean, daily basis. Second easiest thing to control, collets. So for those of us who might not be familiar with collets, collets are the part in the spindle motor that actually holds the tool. And that little part is extremely important. Its responsibility is to keep the tool centered along the axis of the spindle. And any deviation from that center is called runout, or you can kind of think about that as like wobble or vibration. And the more wobble and vibration we have in the cut, the worse things go. And so keeping the collet clean, properly torqued, lubricated, depending on the machine, look at your manual, controls tool wobble, and it just helps things. My kind of rule of thumb is you can't really keep it too clean. You know, every 100 units or so, clean it, take it out, clean it, retorque it, easy. And then the last thing is calibration. Again, it's surprising how many laboratories actually don't calibrate on a regular basis. And if you really think about what calibration is, so the machine is a mechanical device, right? And so it's not perfect. It's impossible to make a perfect mechanism. Ask any engineer. There's always a little bit of mechanical error, and the controller on the computer really can't account for that. And so the longer you run the machine between calibration, the wider that error gets, and it stacks. And so a weekly calibration, like at minimum, will help keep that machine centered. A calibration is telling the machine where home is, and the key is to just not let it wander off for too long. And so whatever your calibration procedure is, whatever the machine is, implement that procedure in your lab. Okay, let's see here. We'll get a little bit further into it. So one of the things that I hear a lot and I really try to combat is somebody saying, oh, a tool is a tool. And that is just not the case, flat out not the case. There's a wide spectrum of tool quality out there in the industry, especially with some of the stuff that's coming in offshore now. You don't know what you're gonna get. And you know, that's why, you know, Sierra prides itself in occupying the upper part of that spectrum and delivering a product that's reliable. And then all in all, we still save labs money even with our premium level products. So that's a really cool thing. The tool quality literally is your unit quality. Bad tool makes a bad unit. Your fit, your finish, the longevity of the tool, it all accounts for labor savings, less post-processing, less time messing with changing tools on the machine, that kind of thing. I wanted to make sure that I noted that you want to look at your tool costs on at least a monthly basis, and some of the biggest operations look at it on a yearly basis. The wider that time, the better the savings looks, because it is there, and it's undeniable when you do the math. But at least look at it on a monthly basis. It's really not about the cost of the tool. It's about the cost of what the tool delivers, and that's machining a unit. You know, frankly, as a laboratory, we bill in units, so we should measure in units. Okay, and then the last thing on stretching your tooling dollar is premature tool replacement. Many times, call into support with any number of issues, and really the first thing that gets said, and we're trying to fix this, is change the tools, throw the tools away, put in new tools. Let's back up to the tire metaphor again. I'm running around in the rain with my bad alignment and my bald tires. I might spin out and hit a guardrail because the tires are bad. I go put brand new tires on it, and now suddenly it runs great in the rain. But that's only a Band-Aid. And so when you put new tools in a machine that's got an underlying issue without addressing that issue, yeah, the problem goes away, but it'll resurface. Guarantee it resurfaces. There's actually a methodology to analyzing the tool itself, and at the end I'll have my my contact info up, and I'd encourage, if there's enough interest, maybe I'll do a group training session on analyzing tools, because that can actually add value for laboratories as well. Okay, this is kind of the hidden best tip of this entire thing. How to minimize internal remakes. So like we really can't take it to 0%, but if you're doing a lot of chipping, most of the time chips are caused by either CAD design. Are you designing with intent for zirconia? We have to keep in mind that zirconia is a ceramic. It refuses to be machine thin. And like our recommendation has always been 200 micron minimum on your margin line offset in CAD. If you try to go thinner than that, you're just statistically more likely to get chips. 200 microns is like the bread and butter. Just stick with that spec and work with it. And then is your mill healthy? Already covered that. So assuming those two checkboxes are checked, a chip is caused by a dull tool generally, and when the tool gets dull, you get a chip. And so here's the procedure for never chipping again. Track your units, run 2 to 3 tool sets through, get good data. Now that we have data, we're going to take an average of that data and then back off your unit count by 15%. Make that your spec, and as long as you don't change anything else, zirconia, machine, whatever in your system, then you can reliably know that that's how many units you can mill on that in that setup, and just change them on a regular basis. Don't wait for them to chip. So let's see, I did get a little rambly here, so I'm going to blast through this one. Production time trade-offs. Every lab is different. Every lab has different talent pools. We encourage people to assess your manual handwork skill set. If you have somebody that's really fast at post-processing and you're trying to pump a bunch of units, maybe it makes sense to run faster strategies. But if that's not the case and you want the machine to do all the work, take that into account. Use the high detail tools. Use the 0.6, the 0.3 for anatomy, and get something off the machine that is more ready to just go right in the oven. Just encouraging everybody to make that analysis. And then, if you're milling dentures and everything, I have to plug our rapid removal tool. That will save you immense amounts of process time. So ask your Zahn rep about that. And then I'm gonna tie this up with a little bit about Sierra. And for those of us who might not be familiar, we've been in this for 14 years. Sierra was the first company to bring a dental-specific CVD diamond coating technology into this industry. And the product market fit is amazing, because on almost zero advertisement, Sierra has grown basically on word of mouth and organic, and of course help with the Zahn team and everybody who pitches in there. But it's really based on delivering the value. All of our tools are application specific. We don't borrow things. We don't just say, oh, this might work for that. We look at every single application and we optimize for it. We also partner with the CAM companies to make sure the tools actually work. That's very important. We offer several different sub-brands. Nanodye, that's your bread and butter diamond tool. 10x carbide as far as life and zirconia. Razor Sharp, that's the sharpest tool in the industry. Proprietary edge technology, best for cutting wax, PMMA, soft bite splint stuff, different denture acrylics, all that stuff. Use Razor Sharp. Tyco, if you're doing some titanium machining or chrome cobalt. We've got an excellent line there. And then finally our G-Max, which is our electroplated diamond grinding tools for your lithium to silicates and other glass ceramics and composites. Everything through Zahn exclusively. You know, if anybody's not already using the product and they do want to use it, reach out to your sales rep. And in fact, I think there's a promo code for this. So those of us who have attended this, I think the promo code is 10% off for anybody who uses the code, which will go out in an email after this. So take advantage of that if you'd like. And ending with this, you know, we'll open it up to questions like Madeline said, but I don't see any in the queue, so maybe there won't be any. Literally anytime you want to drop an email or a phone call, you want to know about looking at tools and analyzing condition of tools, feel free to reach out. You know, we're here to help. And you know what? With that, Madeline, I'll punch it back to you, and hopefully we've delivered some value here, guys.